This question is given in GATE 2008. Okay. Now see this question. The measured transconductance GM of an NMOS transistor operating in a linear region is plotted against the gate voltage VG at a constant drain voltage VD. Which one of the following figures represent the expected dependence of GM on VG? Okay. They are asking the expected dependence of GM over VG. They have given 4 graphs. Okay. With the 4 plots. Now we need to find out which one is the correct answer. Okay. They are saying that the transistor is operating in linear region. Okay. Transistor is in linear region. Now how we are able to solve this is, write down the current equation for the transistor which is in linear region given by ID. ID is equals to Kn into VGS minus VT into VDS minus VDS square by 2. This is the current equation for the transistor in linear region. Now how to find the transconductance is, transconductance is given by the equation GM. It is nothing but differentiation of drain current with respect to VGS. Okay, this we have known. Transconductance is given by differentiation of this drain current with respect to VGS. We will get the transconductance. Now differentiate this equation with respect to VGS. Differentiating with respect to VGS. What we are differentiating? ID. Okay, differentiating ID with respect to VGS. Now differentiate this equation. Dou ID by dou VGS. This will be equal to Kn into VGS minus VT. Okay, VGS minus VT into VDS. Okay, now it is nothing but GM. So if you observe that GM is directly proportional to VGS. Okay, GM is directly proportional to VGS. From this we need to find out which one is the correct. It shows that the linear characteristics, as GM increases, VGS also increases, which means it will be having linear characteristics. So if you observe in the options, only option C has that linear characteristics. No other options. Option A is starting at 0. It goes on increases. Gradually GM will be more increasing compared to VG. So here in the option B, it is growing exponentially. Whereas in the option C, it is a linear graph. We all know that it is a linear graph, and anyway option D not the answer. So the answer is option D. The point which you need to remember here is the drain equation for this transistor, and GM is given by differentiating the above equation with respect to VGS. So from there we can get GM is directly proportional to VGS, such that option C is the answer.